Okay. Hello, everyone. Okay. Hello, everyone. Good morning, good evening, good afternoon, from whatever part of the world you are watching from. It's actually really amazing to be with, and I really do hope you've been enjoying our previous sections and you've been understanding everything that we've been trying to discuss here on the call. So as of yesterday, we rounded up with the fundamentals of Python, and I did mention that we were going to start off today with a summary, and we're going to do a workflow together that's going to kind of sum up a little bit of everything we touched it's going to cut across the data types. It's going to cut across logical operations. It's going to cut across Python functional statements. So it's going to be a very interesting one. So I hope you're actually going to pay very prompt attention, because, like I said, it is going to be very interesting, very interesting workflow. Okay. So before we go on, just quick one for the sake of a recap and for everything Hi, David. Can you hear me? Okay. So sorry for that slight break. Like Okay, yes. So that was a quick thing or whatnot. Because we went deep into Python fundamentals. We actually did get our hands a little bit dirty this week. So that's going to bring together everything that we worked on together. So let me just present the slide. See my screen. I hope you can see my screen because I'm presenting our slide for the week. So remember with this week, everything we covered was Python fundamentals for in data for coding and creating simple workflows. Then most importantly, we went deep dive into Python data types. We went how different string character. We also actually lists. Did a walkthrough on how list works, how to append to a list, how to remove from a list. We also looked at how to be able to make simple calculations with your list. That you can perform like mathematical operations, do like a sum or whatever functions that you want to apply. It will easily iterate over the list. We also looked at how dictionary works as a key value pairs. I remember that we also even created a simple dictionary workflow, and I told you that a dictionary, what I mean by key value pairs is that it has a key attached to a value. This is what makes it a dictionary. And if you are getting data from API, getting data from most JSON records, JSON is basically comes in dictionary format. But data from API always come in JSON format, and JSON comes in dictionary format, right? That's with the key value pairs. Then most importantly, we looked at conditions and loop. And what are conditions to your tax? And we're actually going to look very deep. We're going to do a deep dive into condition and loop using the workflow I created for today. So, and I explained that most times, most data pipelines, especially for transactional purpose, they mostly work with a condition and loop because it is not most likely one decision that is going to be made. So it's will have to go through and iterate over separate conditions before you get a final result. So, and I told you that you start your condition with your else if statement. So if you have your if, the next statement will then be the else if. So if you have your if and you've stated your first condition, if it doesn't match the first condition, if it doesn't match the first condition, then it will go on to the else if statement, pick in the next condition. If it doesn't match, then it will come to the if statement. So it came to me that the only loop that we did discuss was the for loop. So I taught you intensively how to use the for loop to iterate over a list using this example right here. So a for loop is basically a loop that will iterate over a list. it will go through each and every object in that list you want to create. So you can use a for loop to easily do this. So meaning it is going to keep going until it goes through every single object in that list. So that's how a for loops work. That's how a for loop work. And there's another type of loop called the while loop. And the while loop is what we're also going to look at intensively today to make our workflow successful. Now, I went into function and I discussed that function is building block of it's like a list, like building blocks basically of maintaining data pipelines. And I said that if you have like a list of code that you know you're going to be writing over and over again, or you know that the codes are going to have to serve a particular purpose over and over again, it is best practice to wrap up that code in a function. So you then give it a function name. So whenever you need to make use of that code, you won't need to start writing every single task again. The only thing you just need to do is just to call out the function name. And if it has any arguments that you have to pass to that function, you will pass the arguments and you will get your results. So with the example that we gave, I'm going to open our Jupyter Notebook very soon. So would do a recap on the example we gave with building a function and designing a visualization. Okay. So then for functions, you might want to make things more structured. So a module can allow you to put in different functions into a file, right? So that file is then called a module. So you can then import that module into your project and make use of the function in that module. And I told you that this is just the way you create your own custom module. You create a Python file, you add functions into that Python file, then you can now read that Python file into your workspace and get functions from that file. These are the functions that have been defined in the file. And I tell you that Python on its own, it comes with its own standard modules. Python comes with some example modules like JSON. This JSON, you can see, it comprises of many functions. It has lots of functions in it. You have your JSON.load, you have JSON.dump, you have JSON.load without the S, and there are different type of functions that are present in the JSON module. Same situation goes with date time, same situation goes with operating system, OS, and so on and so forth. And I go off that more the theoretical parts to go through, but we are going to look at everything again in our Jupyter notebook tonight. Then I went really we did a deep dive on 5 fundamentals. And I said there are different types of file that you work with at most times. You work with CSV file, you work with Excel file, you work with JSON file, and so on and so forth. And I taught you 3 different ways to work with all the types of file basically. And we went through the first normal method where you use the regular Python function, that's the dot open function. And I explained to you that when you're using your dot open function, you have to be sure you are doing a dot close afterwards, because it might cause latency, it might cause lagging, it might cause so much open and delay in your workflow and in the application that you're picking your data from. Then after the regular dot open function Python, there's another function called the read statement. And I told you that the read statement is much more preferable than the regular dot open function, because if you use your read statement, automatically it closes off the transaction for you. So once you do your with open and you set your of what you want to perform, which in this case, if you want to do a read, you use the W mode. If you want to use the read, sorry, you use the R mode. If you want to do a write, you use the W mode. If you want to do the append, you use the A mode, and so on and so forth. So that's how it works. So that's how its open statement works. Once you open that transaction, you get you want to do under that with statements, and that's it. You don't need to think of remember to close or make any other statement because the file has been settled that way. Then I showed you the final way of handling files, which is through pandas. And I explained to you that pandas is a standard library that comes with Python. And the library has a lot, it comprises of a lot of modules, comprises of a lot of functions. And the most important function of pandas is to be able to work with files, to be able to, and not just work with files, to be able to work with data, manipulate data, transform data. You can also use pandas to even write to a data. So I showed you the simple way to use pandas to read from a CSV. You're only going to use the code .read_CSV. Then it stands for this is the argument the function is about to take. You put in the name of the CSV file to be read. So this simple line of pd.read_CSV is pandas way of reading the CSV file. And I told you in the case of you reading a text file, a txt file, the only thing that will change will be the prefix. So instead of it being, oh sorry, this will be the suffix instead. So instead of saying read_CSV, you will convert that to read_txt. Or in the case when you are about to read into a Excel file, you convert that to read_Excel. That's EXCAL, the suffix right there. So it is a very simple way to work with files without too much manipulation. And if you want to write to a CSV file, you just simply use the syntax .to_CSV. So, and what argument does it take? It will take the name of the CSV, like what you want to call that CSV file. And the reason why we put index equals to false is that Python comes with natural index, a data frame, not just Python, data frame, pandas data frame. It comes with its own index. What I mean by index is that it comes with like its own row numbers. So we have 0, and I told you start from 0. So if you don't want your file to come with that data frame index, you can set index equals to false. So this way, the only index that will be there will be the one you set yourself. So if it's like the row number or whatnot, the one you set yourself is the one that will get translated into the CSV file you're trying to create. Then I showed how to work with JSON file. I told you that JSON is most like a file with a lot of hierarchy. Like it has nested structure. So it's like a list of a list. And most times it's like a dictionary of a dictionary. So I showed an example of how complex JSON file looks like. You will see like a header, like one column that is going to have nested values inside it, and that nested values might also have another nested value inside it. So working with JSON is not just a generic thing. There are different formats in which different JSON comes in. So the best practice is to first look at a sample of the JSON file so you know how it is structured. So once you know how that JSON file is structured, that will be the best way to then know how you handle it. But generally, if you want to open a JSON file to read the JSON file, you have to import the JSON module. So if you do your import statements, do your import JSON, then you can use some functions in the JSON module to be able to work with your JSON data. So how do you start the transaction? Again, with our with statements, we'll do our with open, and in this case, we're opening a JSON file. So if we do with open as F, so in this case, F is not the alias for the file we've opened, then you load the data using the JSON.load. This yesterday was APIs, and I explained to the API is basically just a middleman between you and another system. It might not necessarily be between you and the system. You might also want two systems to speak to each other. It is through an API, because through API, one system can request for information and The API will then go to the system it is requesting information from, get what the system needs, and return it back. So if I'm using the example with you, you can make a call to a system, the database, a file, a URL, whatever the case may be. You make your request to through the API, then it is going to return a response back to you. And I told you the way you work with an API is through an endpoint. Every valid API is works through an endpoint, and an endpoint is a URL. So this URL is what you will connect to using the request function. And I said the request function is a function that comes with Python. It's a standard Python function that you just import in your workspace. If you do your import request, you have your request function. So think of, and as I gave this brief example of thinking of API like you're ordering from a restaurant. So you are the client. If you make a request to the server, which in this case is the waiter, so you specify what you need, how you need them, how you need it to be cooked, and so on and so forth. Then the server will process request and return a response. How is it processing the request? It is not the server, that's aka the waiter, that's actually making the food for you. It is just a middleman going to the chef, telling the chef, oh, this is what you need, this is what you need returned, and it will return back the response, which is in this case, it's your food, return it back to you. That's the same way an API works. It stands in the middle. You make a request to the system you need through the API endpoint, then it is going to go there, connect to that system, get the response you need based on what you specified, and return it back to you. And API returns data in a JSON format. So you will have to then do the gymnastics of transforming the JSON into a regular data frame. So depending on how the JSON format works, depending on how the transformation will occur. And I mentioned something yesterday quite briefly that every API has something called a dictionary. And what I mean by dictionary is not dictionary data type in Python. No, a dictionary is like call it the book of the API. So if any system is creating an API, they usually do create a dictionary that will tell you how the data is, because you don't necessarily know how the data is being stored on their database. So you don't know the type of columns that are there. You might not know the type of fields that are there, or the data types of the columns that is being stored in that database. The only thing you know is the API, that's the URL link. So that dictionary is going to tell you this is what you should expect from this data. So based on that dictionary, you can then make your specifications to specify that, okay, I would like to get these columns, this column and this column, depending on what you are trying to achieve, right? So you need to also check for the data dictionary, so you'll be able to have a clear understanding of what you need to achieve. And this is most likely for private APIs, where you will need to get like authentication token or whatnot. But most public APIs is just straightforward. You just call it and you just get exactly what you need. An example is the API I used yesterday for the sample in which we worked in class. It's just a very simple API that contains customer data. So you can just use that for practice sake, to be able to get to see how an API works in real life scenario. So we did a simple request function. So you will connect, make sure you have your URL, which is API endpoint. Then you are going to use your request.get. So you are telling the request that go and get data from this URL, get data from this endpoint, and store the data in a variable called response. That's what you are doing. So you do your response is equals to request.get with your URL. Now the next step, like I said, the Python, this data writes like a HTML format. It is just getting everything from the URL. So if you want to now pass it into a JSON format for it to be able to stream the data properly, that is where we have the third line of code, where we have the data equals to response.json. So you convert it into a JSON format for it to be easily read. Then the next step we did was convert the JSON into a data frame. So this was not the example we used word for word. Then also explained on some best practices for when you're working with file, you have to first of all inspect the column and data type after reading the files, or and in most cases you don't even know what you're expecting. So to better structure the way you are going to build the workflow. So and I explained also on so I told you about the try and accept block, in which you can use to wrap up your codes. So if you tell your code, okay, try this, and if it doesn't work, then accept and fail gracefully. Don't just fail without meaning what failed. Fail gracefully in the sense that let me know the error that that was encountered, so you can easily debug, correct the error, and move on from there. And document your data. Always document the source, document the extraction date, document the schema. Any single thing you apply, you put into work in your workflow, it is best practice to document, so you will know exactly where to tweak things from. And not just you, but even future teams will actually appreciate it a lot. They work we discussed on data types. I showed you how sort is used to via range the data. The work we discussed on data types, I showed examples of some working with different Python data types, inflow, we looked at lists, we looked at dictionary, tuple sets. I remember one thing I mentioned earlier that immutable, like you don't need to overwrite the name of the variable or overwrite the name of the list. You can easily add to the list, or you can remove, and I showed you how to override the name of the list. You can easily add to the list, or you can remove it, and I showed you easily how that is done with the various functions, even via it being a list. An example of this function is your dot sort, and I showed you how sort is used to rearrange the arrangement in like an order you actually want it to be in. Okay, and I also showed you how to like calculation your list in the argument, and it is going to simply do a quick calculation to calculate the difference between list and tuples. First of all, is that tuple comes with a regular bracket, that's the rounded bracket, and the most distinguishing thing about that it is immutable. Once you've created a tuple, you can't add to it, you can't remove from it. You have to recreate that variable. I know that it's very easy for you to recreate a variable in Python. You just simply mode and all your variables are refreshed accordingly. Then I told you how to use set is unique. Set is, oh, it also comes in a curly bracket, just like dictionary. So you can only have unique values in sets. And in this case, with this example I gave here, you can see the key is ID, and you have another key of amount with the value of 150, and so on and so forth. So that is how a dictionary works, and based on that, you can be able to work with and also And I did explain on operators. I said there are different type of operators. We have the arithmetic operators, and these are the three most common type of operators used in daily workflows. The arithmetic operators is as simple as it does and extra. The most important one I wanted to bring to your attention was the comparison. So I explained how comparison operator was going to compare between two. And I said the equals to sign stands for its value equals to the other value, because in Python the regular equals to sign, it has been taken over by the function of assigning a variable. So the single equals to sign in Python, you only use that to this object to a variable name called customer. So because our source of comparison is gone, so in Python, what you use to always equals to sign, if you want to note of it, if an object want to show is that there's let me be sure this works in Python before we move on. Okay, it doesn't work in Python. But in SQL, another way to do a double a not equals to is to do SQL classively on functions, and I showed how a simple workflow we created yesterday. So the name of this function was called get big spend. That is quite interesting. And the function was to take in two like what is the data it is taking in. The second parameter needs to be, you have to set the limit when you're calling the function. So what the function does is that first of all it's going to create an empty list. So in this case it's creating an empty list called results. Then it will iterate over assuming that the record is going to have a column called amount in record is greater onto our empty list called in we append that output into our empty list called results, right? And at the end of the day, it is going to return our list with all the amounts that was greater than the limit set. Okay. So sorry about that technical glitch. I think it's my network is it keeps going on. Okay, so I guess we are live now. That's what I was explaining. We had a workflow that we created with this simple function called get big spenders. Argument it takes in. So it is great to also iterate over the working with files we went through yesterday. So I showed you how to open a file with your regular .open method. So we have our open our open function that takes in two important arguments. The first argument is the name of the file you're trying to open, or in this case, we want to write into a new file. So it will be the name of the file you're trying to write into, then the mode. And in this case, the mode is our, so use the mode as W. Then I showed how using the line in the speaker is not breaker there. It is going to be on different rows. This is for a TXT file. So I'm not really going in depth into it because I don't think you necessarily even need it more often. So the most important file we looked at was CSV. And I showed you three different ways of working with a CSV file. So either you'd have worked with a CSV file with our regular open statements in Python. So that's this type of transaction, which you have to close off with a file dot close. Remember I said any file you open, you have to close it. And not only that, if you're working with a CSV file, you have to, if you're using the regular even if you're using the read statement or the regular open statement, you have to import the CSV function. So there's a function in Python that comes like it comes with every Python you download called the CSV. So you need to import the CSV function. So you'll be able to use certain the CSV module, sorry. So you'll be able to use certain functions in the CSV module to complete to work with a CSV file. So in this case, we created a new CSV file called products.csv and we opened it in the write mode, that's with our W mode. So we'll be able to write into that CSV file. So what are the functions we made use of? We made use of the csv.writer. So this was what made us able to open that file for it to put it in write mode and for us to be able to write the data into it. Then the next step we used was the dot write row function, which is to now write the records, putting this data into our open file. And I thought that all this method can be quite stressful. If you want to work with CSV, the most recommended um, approach would be to work with a pandas. What pandas? And I think this we can just simply use the keyword PD. So and I told you if you're reading from a CSV, it is very simple. You will use your pd.read_CSV. Then you can read into the CSV and perform what you want to and make any transactions you want to make or perform any transformation you want to create to the file, right? So you don't necessarily need to use the read statement all the time, but you need to know it. So to depend on the scenario you're working on, you will know the type of or statements, the type of approach to use. But 80% of the time, you most likely have to use pandas approach because it is easy, it is simpler, and it is straightforward. Okay. So then moving on to APIs, this was the URL we made use of yesterday. It's a simple URL that contains user data. So we made a request to this URL using our request.get, and we stored the response in our variable called response, which we then passed into a pandas data. Now the data was what we then converted into a pandas data frame. And I told you the importance of converting to a pandas data frame. It makes your data easily accessible, and you can perform manipulation analysis, what's not on that data, as long as it's in a data frame, right? Data in a data frame, it is much more easier to work with than it being in a regular in a regular format. Okay, so take for example, let us see how the data will be in our regular variable than how it will look like in a data frame. So I'm getting a request to the URL, and I've stored the response in our variable called response. So now I'm running this code to see how the data will look like without converting it to a data frame. So now let's try to see the output of our data without converting to a data frame. You can see how it looks like. It looks like a regular JSON file. It has the key, it has the pairs, it has the key, sorry, and it has the value, and so on and so forth. But this is not readable, and you can't perform proper analysis on a data like this. So hence the need to transform it into a data frame. And how do you transform it into a data frame? You use your pd.data frame. I remember I told you that PD stands for pandas. It is an alias form of pandas. So if you do your pd.data frame, then in brackets, what is the data you're trying to convert to a data frame, which is our data that we stored here as data. So we stored this as data. So now we are passing it to the data frame function to convert it into a pandas data frame. So now let us run this code and see how it looks like in a pandas data frame. So now you can see how better arranged it is, and it looks way better than it is on a regular variable. So you see that here we have each of the rows, each of the columns properly laid out with the values. So you can easily see what you need and easily get perform analysis or manipulation on this data without the need of trying to still pass in an except block. And I mentioned it is a way to try to wrap up your code that it won't crash without a proper backup. So even if the code is to crash, you will have to give you the exact reason why the code crashed, and you'll be able to easily debug and know what went wrong. Okay. So then we created a function in which we use to simply extract data from our URL, which in this case we made the API. The URL is the API endpoint. So the function was just a very simple function to go to this endpoint, get data from the endpoint, store it in a response, convert the response to pass that HTML form response properly into a JSON file. And this is where we stop for the course of the function. But I told you can also taking a step further to convert it to a data frame so it to be properly readable. Now, what we have for today is to go through a workflow together. So what this workflow is going to do, and really hope you pay prompt attention, what the workflow would do is to iterate over loops. We are going to also look at conditional statements. We are going to look at comparison, that's with comparison operators, and we will see exactly how it works. Now remember, I said there are two main type of loop. The only loop we've touched on so far is the for loop. And I explained that there's another type of loop aside the for loop, and that loop is called the while loop. WHILE, the while loop. And this while loop And how the while loop works is that it is immediately going to set a condition, and as long as that condition remains there, the flow will keep on working. It's like a cycle. If it gets to the end, it will continue from the beginning. And the dangerous thing about while loop is that if you don't put a proper stop or a proper measure to stop that loop, it will keep running and running and running until the system crash. So most likely you need to set, either you set a stop to be able to pause that transaction if there's any error, or you want the transaction to keep going over and over again, you make use of a while loop. Okay. Now, what do you mean by putting in a stop? There are different type of stop, but the one I'm going to explain today would be the break. Will be the break. The one I'm going to explain today will be the break command. So if you are working with a while loop and you use the break command, it is going to stop the loop. It's going to like take you out of that loop without it going over and over in this in the circle again. A loop is just a very simple thing. It is saying that it will keep running. Like if it goes through the end of all the transactions, start again from beginning, keep going through it, keep starting again, keep going through every single transactions. So if you don't put in a setting like that to be able to monitor and to be able to manage the workflow, it might just cause a system crash without you even understanding what went wrong. Okay. Now, like I said, this is a very interesting workflow. So you actually need to pay attention for it to know exactly how it works and for it to be able to replicate something similar on your end. So I told you the purpose of this workflow is going to act like a bank. So this workflow is going to more specific. The workflow is going to act as an ATM machine. That's what this workflow is going to do. So in this workflow, you have your account balance. So before you start the transaction, it is going to ask you what you need to do. Then, based on whatever option you pick, if you want to check your balance, return that output for you. If you want to make a withdrawal, it will return the output for you. If you want to make a deposit to add on to your balance, it will return the output for you. And if you want to just stop the transactions, I told you to keep on repeating it over and over again. But if you want to leave the loop to end transaction, it will also carry out that task for you. So that was the summary of this workflow. Now let's look at it step by step and see how it works. So first thing first, we set up our variable for our balance, and I set our balance is 100,000, right? So I ran this code to set a variable for our balance of 100,000. Then I created an empty list to be able to collect all the transactions we do. So you can be able to go back and look at the transaction history for you to see everything that you've performed on your for you to see everything you've performed on your account, right? So hence this empty list. So whatever transaction we perform, we are going to append, meaning we are going to add all the details of that transactions into this list. So we can then convert this list to a CSV file and be able to look at it afterwards to see all the transactions we performed. Okay. Now, the start of this workflow, we'll use a while loop because a while loop, like I said, it is going to keep running as long as that condition is set. And in this case, I'm not necessarily setting a big condition. I'm just telling it while true. So as long as true is every statement here is true, like the transaction is starting, the loop will keep on going unless you break it with our break statement, which we will see how it comes into play very soon. So the beginning of the transaction, as you can see here, we made a simple print. What So depending on what you want to perform, you are then going to impute that option into a value. That's the first thing it's going to ask you. It is going to ask you to impute to put in a number. And there's a function in Python that you can be able to do that. It is called the input function. So the input function will give the user the ability to put in a number. Enough talking, let us see how it works. So I'm going to start the this transaction. I'm going to run this code. So as the code is running, we will see the different ways the different flows it takes. Or no. Before we start the code, let's actually go through every single code. Let's go through all the conditional statements before we go into that. So take for example, if you input option one, and remember option one is to check balance. So we will now start our if statement, our conditional statement. We will then say if the option is equals to one, meaning if the user should input one. Remember, look at our logical, our comparison operator here, our equals to sign. So it is saying if I should put in one as my input here, so if my option is equals to one, it is going to perform the transaction of checking balance. And it is very simple. What you just need to check balance is to return the current balance. Now you might be confused that what does this F mean? This thing is called an F string. So in your print statement or whatever statement you're making use of, if you have a variable that you want to call in that statement, remember that our balance has been stored as a variable. We have our balance right here. Balance is equals to 100,000. So this balance is a variable of its own. So if you want to be able to get the value of a variable in a statement you're making, you use an F string, because the F string will allow you to type normal English and still put in your variable name. So you'll be able to dynamically get the value of that variable. So I hope I was able to explain that clearly. But if you don't, you can make further if you can make further research on it. So that's just what this F string means. So if I pick option one, it's going to just check the balance. And what would that do? It will just return my current balance to me. So in this case, my current balance is 100,000 at the start of the transaction. So it's going to return it to me, and it is going to append into our transaction history, because we want to be able to see all the different transactions we perform on the account later on. So this is the name of our list that we created, transaction history. So it is then going to append the transaction we made into transaction history. So remember, we are still in option one, check balance. So what is the transaction type? Transaction type is check balance. Obviously, there was no amount that was involved because we did not make any transaction, and the remaining balance after this transaction will be the amount that is in your variable called balance, which we just called right here as balance. Now, what if we didn't choose option one? Using our condition statement, we then used if. So we now do else if. I told you if means else if. So if you do not choose option one, you choose option two. So if option is equals to two, you have to input. And remember, the option two is to withdraw money. So you are trying to withdraw an amount. So again, we are going to make use of the input amount. And the reason why we converted it to an integer, why we wrapped it up as integers, because we need the amount to come in as a number. So we'll be able to do a calculation on that amount. So we'll be able to do a calculation on the amount, because obviously when you withdraw money, your balance has to change, right? When you withdraw money from your account, your balance has to change. So your new balance will then be your old balance minus the amount you withdrew. So for us to be able to do that calculation, we need to make sure our amount is an integer. So that is why we wrapped up the inputs in an integer, as an integer data type. Okay. So if you choose the option two, you are going to input an amount. Once you input the amount, it will get converted automatically to an integer. So we'll be able to do our calculation on it. So now, under this condition, it's not every time your withdrawal will be successful. What if the amount you are trying to withdraw is more than the balance you have in your account? How would that transaction go through? It won't be allowed to go through. So we'll be setting the inner condition. So and then saying that once you've written your amount, if the amount is greater than the balance, or it is going to print out low balance, transaction declined, right? then what is it going to do? Again, every transaction, we want to see a history of every transaction that was made, whether the transaction was successful, whether it was failed or declined or whatnot. We want to see that history. So that's the reason why we are also appending the outputs into our list that we created, transaction history. So again, just the same way we did for check balance, our transaction type is the name of transaction type is withdraw failed, right? Then in this case, there's an actual amount that was withdrawn. So the amount that was withdrawn will be the amount that you imputed here. So amount will be our variable amount. Then the remaining balance will be the balance of your transactions of your transaction after the the balance will be it will be your regular balance because no transaction was made. Remember that the transaction did not go through, so your balance will still remain the same. There's no need to perform any there's no need for any subtraction or whatnot because the transaction did not go through. Okay, now the next step under this same inner condition is then if the amount is greater than the balance, obviously the transaction is not going to go through. But else, if the amount is not greater than the balance, you can notice that we did not make any other conditions because there are only two options here. So it is either the amount is greater than the balance or the amount is less than the balance. If there's greater than the balance, you would have your transaction else, which in this case the amount should be less than the balance. What we now have to do, you have to make sure the amount is then subtracted from your current balance, and the variable from your for your balance will change. I told you it is very easy for you to rename a variable. Once this transaction runs again, the new value for the balance will change. Then we made a simple print statement again using f string. We made a simple statement using f string to be able to print out transaction successful with the new balance. Okay, and the new balance in this case, it is going to capture the value of this balance that we wrote here. Okay, so again, remember every transaction we made, we want to see the history. So we will also appended the output of this transaction into our transaction history lists. So now the first thing first is we put the transaction type, which in this case was a withdrawal, a successful withdrawal. Then the amount we withdrew, which is the amount that we imputed earlier on. Then our remaining balance, in this case, to be the new balance that was created from this calculation. Now, remember that this is for option 2. Now, what if we choose option 3? Remember, option 3 is deposits. So the same way we converted the value to an integer because we have to do a calculation on this. It's the same way we wrapped our input in an integer, just as when we are withdrawing, right? So it is the same input. You have to input an amount. Then once you input an amount, it's a very simple workflow. You just need to add the amount onto your current balance. So then we use our f string to print out a simple statement to say the deposit was successful with the current balance. Again, we appended the output of the transaction into our list that we created, transaction history, with the details of the transaction. Now, what if you didn't pick option 1, you didn't pick option 2, you didn't pick option 3, but you picked option 4? So in this case, what option 4 would do would be to break the section, because like I said, option 4 is to stop the section, because if you don't stop it, it's going to keep looping over and over again. Okay, so what if you don't impute option 4? You don't impute option 3, or you don't impute option 4, the now what if you do not impute option 1, you don't impute option 2, you don't impute option 3, or you don't impute option 4? The workflow is just going to simply print out invalid option, try again. So it's a very simple option, it's very simple workflow that it has four main conditions. The four main conditions is either option 1, option 2, option 3, option 4. And now for option 4, option one and for option two, which is very delicate because it involves withdrawing money, it has two inner conditions. Number the first condition is if the amount is greater than the balance, obviously the transaction won't go through. Else, the transaction will go through because the amount will be less than the balance. So that's the summary of this workflow. Now let's run the code and see exactly how it returns our output. So once you run the code, you can see right here the first line it gave us was the print statement we made. I told you this sign was just a fancy design just for us to be able to see the menu clearly. Remember, this is the backend code for it. This was how we created that with the four print options. So it's now telling us that okay, what do we want to do? Do you want to do option one, check your balance? Do you want to do option two to withdraw money? Do you want to deposit money, or do you want to stop the transaction? So in this case, let's start with option one. So I input one. So now with it gave me the output. The simple thing it did just check my balance. So my current balance, you can see the output right here. It says your current balance is 100,000. As simple as that goes. I remember I told you this is a loop. So you can see automatically it has asked again for me to put in an option because it will keep going unless I stop it. So it has asked again for to put in an input because it is a loop. It has stopped the transaction from giving me my current balance, but it will start again because I did not break the transaction. Now, in this case, let's start with option two. So we want to withdraw money. Remember all the conditions now withdraw money. So let us try and put 120,000, which in this case, remember, it is greater than our balance. Our balance is currently 100,000. So let us try with number 120,000. You can see because of the conditions that we set, it's replied low balance transaction declined. Okay, and again, just like I explained, it is a loop. So it is telling you to start again because we didn't break the transaction. So we are going to keep on going. So now let us try to withdraw money. But in this case, let's withdraw money that is within our balance. Don't let's do pass ourselves. So again, option two to withdraw money. So it is with the options we said enter an amount to withdraw. So in this case, let me withdraw just 10,000. So remember what it is going to do. 10,000 is less than our balance, so it is going to be successful, and it's going to print out our new balance by subtracting the amount from our current balance. Okay, so now you can see transaction successful. Your new balance is 90,000. So now let us do option one again. Let us check our current balance. So you can see you will see how it is going to pick the current value in our balance variable. So now we have our option one. You can see the output. Our current balance is 90,000. Now let's try to deposit money, which is just simply going to add onto our current balance. In this case, that is option three. So enter an amount to deposit. Let's try and deposit 20,000. So it said deposit successful. Your new balance is 110,000 because it's added the 20 onto our previous balance. Okay. Now, if you are tired of this workflow, yeah, if you are tired of everything you are doing at the ATM stand, this is our ATM stand. We are then going to stop. So if you put option 4, it is going to break the loop, and you will see the output right here. It has stopped the loop and it is just telling you what we printed out, stopping section, goodbye. So it is because of this break function that we put right here is what is going to stop the section if our option is equals to 4. Now, let us see the value of our transaction history. Remember, our transaction history is a list, right? So now let's convert it into a data frame using the pd.data frame. So we'll be able to easily see how the table is, okay? So now we have our DF as a data frame, which is data frame consisting of our transaction history. So now let us print out our DF to see how it looks. So you can see all the transactions we made. The first transaction we made was check balance, which obviously it was a zero amount charge. and our remaining balance after that transaction was 100,000. The second transaction we did was to withdraw, and we withdrew 50,000, and our remaining balance was 50,000. The second transaction we did was to check the balance, and in this case, all these transactions I did testing out the code, but this is where we started from. With that, where we did it together, we started from this transaction. We checked the balance, and you can see the transaction history here. You can also see when we tried to withdraw 120, which was greater than our current balance. So the transaction type was withdraw failed, and as you can see, our balance remained the same because the transaction did not go through. Now the other transaction we did was to withdraw, and to successful because we withdrew 10,000, and our balance after that was then 90. We also did a transaction to check our balance, which was option one. And as you can see, that nothing was changed because it was a simple check. We did not set any, we did not set any calculation to make the balance change if you choose option one. Now you can see the final transaction we did. We chose option three, which was deposit, and with the calculation we set for option three, it is simply going to add the amount onto the current balance. So you can see how Python can be used to create a real life scenario on how this is the back end of most of the applications you see. Python is the back end of most applications you see, of how it keeps running and giving you the fancy code, and in the front end. The back end is working with a Python script just as similar to this. So now we are also going to you have a quiz that you're going to carry out on your own to build something as similar as this. Now I did not just come to like write all the code at once. You build it line after line. So depending on what you want to achieve, that is how you will keep building your code. So in this case, I already knew what I wanted to achieve. I wanted to achieve something to be able to um get 4 options. Based on the option, perform a transaction. So based on that, I was able to write out each line of code that is going to perform that transaction you need. So you are going to get this code base, so you'll be able to try on your own and see the output on your own, right? So now the last thing I did here was to then convert this data frame into a CSV. I transformed it into a CSV so I can easily send it to the business users or send it to anybody else that needs to make use of it. Your transaction history, as simple as that. So I hope this from through this simple workflow, you understand better how conditional statements works in Python. You understand better how the loop works. In this case, we looked at while loop. You understand better how comparison works, logical operator works with the equals to sign. That's the double equals to for comparison, the greater than sign, and so on and so forth. And there's also another thing we also touched here. You can see how we were able to keep appending. We were able to keep appending into our empty list. And we were able to keep writing values into the empty list. Okay? So it's a very interesting workflow that would make you understand better how all these functions work. In this case, the loop statement, the conditional statement, logical operators, and to convert to a simple CSV. So I wish I would be able to communicate with you to understand if you have any question, but you can easily drop it in the comment section. I'm actually looking at the comment section now, so we'll be able to walk through it together now that we're on live. Okay. Okay. Say how can you install Jupyter on your system? You are going to the first option there. You basically just download it. It's nothing serious. So based on the type of system you're working with, you download your Anaconda. So once you do that, it is going to lead you to a way to you can see the free download here. So once you press on this button, it's going to your system. So once the application is already running, you will just simply go onto your account right there. So let me open a new workflow. And it opens this way. It is going to open up as your paths. So the only thing you just need to do is just type in Jupyter Notebook. So I just need it to open up. Then we'll move on. I don't want to cancel the current Jupyter I have running. So let me open a new terminal. Okay, this is taking what I've guessed it won't open because I have it. Okay, it has opened. So once you open you install it, you follow the prompts, it is set up on your system. You will just simply write Jupyter Notebook. That's all. That it is going to launch a Jupyter Notebook to any browser you have. So once you install Anaconda and through anaconda.com, you follow the prompts to install it onto your system. It's very simple installation. Then you launch it. Once you launch it, just type in Jupyter Notebook. I don't want to press enter because it will scatter my current. I have a lot of workflows that are open. I don't want to mess up. But you just click on enter, it will automatically open a page like this. It would lead you to the home page. So you just click on this home page. So through this home creates you can create a new workbook, which is like this our workspace we're working with. So in this case, you just click on the Python kernel. So it is going to use a what it means is that it is going to use Python engine to open the workspace, to open the notebook, sorry. So that's exactly how to install Jupyter on your system and replicate what we did in class for easier practice. So again, download Anaconda, install it on your system, launch it, call Jupyter Notebook, and that's it. It's automatically going to open on any browser you have. Any current browser you have, it automatically gets launched there. Okay? So if there is any other question, because the purpose of our session today was for to do a recap and to see a simple workflow that was designed to show you exactly how conditional statements works in real life scenario. So it is best time we ask questions now, because if there's no question, then we want to end the session for today. Then we'll meet on our next class on Monday. Okay, so I'll take it to say that you understand the workflow that we created there and you understand the basic fundamentals of Python, because from our next sessions next week, we'll be moving into working with database in your Python. So we'll be working with SQL in Python. So in this case, I remember that Folon did a very good job explaining and you did a very good job on explaining SQL concept and SQL language. So we'll be seeing how to work with that in Python. This is what we'll be starting with next week. So we'll create a simple workflow from extraction to transformation and ingestion into a database using Python. Okay. Busayo asked if API and scraping is the same. No. So scraping is you are trying to get data from a web page. Scraping is you're trying to scrape the web. So let's take for example this web page. If I should use web scraper, and I think the function for scraping in Python is called beautiful soup. Yes. So Yes, that's actually the name. The function in Python beautiful soup imports beautiful. So beautiful soup is a function in Python that you can use to scrape a web page. And this is an example of a web page. Any page ending with HTML, any page at all that at least it has, you know, before we even go too far, I don't know if you know as some basic understanding of how how web pages are designed. Web pages are written in HTML. Okay, web pages are written in HTML before they get they now get designed with CSS to give you a very beautiful interface. Web page is written in HTML, so as long as it is written in HTML, you can use beautiful soup to scrape data from that page. So beautiful soup is just to scraping is to scrape data from a HTML page using the function beautiful soup. But API is like I said, a middleman. It is through a URL endpoint. It's going to connect to where your data is on that other system. You will make a request, it will get data and return it back to you. So they are not the same thing. Scraping is to scrape data off a page. API is to connect you to a different source in which you get your data from. Okay, so I hope that explanation was clear, and I really wish the section would permit. And I would also love to show you how to scrape data from web, but we will see how our classes go next week. And if you're able to finish in time, I would teach you how to scrape data from web using the beautiful soup function. Okay. So is there any other question we'd like to ask? Any other fundamentals you'd like to know before we will end the section for today? Then get ready for our section next week. And Busaya, I hope that was clear. The explanation was clear between API and scraping. Okay. I would like to assume she's still part of us and she quite understood that. Okay, so if that will be all for from us tonight, thank you again for having me and thank you for giving me your attention. And we are going to see again next week with another interesting section. So again, I will share this file with my colleagues so to get uploaded to LMS so you can practice throughout the weekend in preparation for our classes next week. Okay, so stay safe and good night.